What's the fastest way for us to get the inverse of a matrix? Right now, we have a 3 by 3 matrix, and just imagine you are in an exam hall and you have just 2 minutes to solve this problem. That is to get the inverse of this matrix. How do we do it? There are a lot of ways to get the inverse of a matrix. You can decide to go by the matrix of cofactors and so on, but that will be way too long. You can decide to use the identity matrix to solve this, but that will also be long. But there is another way to solve this using the row reduction method, and that's what we are going to be using in this video. We are going to be solving this matrix as fast as possible, and we're going to get the inverse of this matrix. But by the way, if you have not watched the video that I did in row reduction, you can do well to go and watch it and then come back and join us in this video so that you understand this better. But if you don't mind, you can still continue with us in this video. So the first thing that I'm going to do is I'm going to just remove this line that I have here and then add some symbols or some alphabets to our row. So right here I'm going to just augment this matrix and then add some alphabets. I'm going to use X, Y, and Z, and so we have something like this. So the next thing that I'm going to do is I'm going to start the row reduction. I'll start reducing this matrix to its canonical form. So I'm going to try to make this matrix to look exactly like what we have here, that is the identity matrix. And so the first thing that I'm going to do is I'm going to look at this place. What we have here is 2, but I'll try to make it to look like what we have here. And right here I'll have 1 here. So how I'm going to do this is I'm going to either bring this third row to be at the first row, or I reduce the first row by using the multiplicative inverse of 2 to multiply it. So I'm going to do the first one. I'm going to use the multiplicative inverse of 2 to multiply everything that we have in the first row. And so we'll have something like this. So multiplying this by 1 over 2, we'll have 1 here. Multiplying this by 1 over 2, we have half here. And then multiplying this by 1 over 2, we have 0 here. And then we'll also multiply x by 1 over 2, so we'll have 1 over 2x. And so that's our first result. We write out the remaining the way they are. So we'll have 0 here, minus 1, 1. I'll have 1, 1, and 2. And so we have z here, I'll have y here, and that is what we'll have in the first iteration. So the next thing I'm going to do is try to reduce this to 0 using the first row. So we have using the first row to reduce the second row, and there we'll have 1. The additive inverse of 1 is minus 1. So I'm going to multiply everything that I'll have in the first row with minus 1 and add it to everything that I'll have in the second row. And so we'll have something like this. After doing that, the first row will still remain the way it is. So we'll have this 0, and then we have 1 over 2x, and then the second row will still remain the way they are. We have 1 here, 1, y, and then multiplying the first row by minus 1, adding it to the third row. Oh, sorry, that's supposed to be 1 comma 3. So adding to the third row, have 1 times minus 1 will give us minus 1 plus 1. We have 0 here. Then minus 1 times half, that will be minus half plus 1, and we'll have 1 over 2 here. So multiply minus 1 with 0, have 0 here. Then plus 2, I'll have 2. So if we multiply this by minus 1, we have minus 1 over 2x. And we add it to what we have here, we'll have z here. So we'll have 1 minus 1 over 2x plus z. And that's it. So the next thing that we do, find out that this is already looking exactly like what we have here. So we'll go to the second row and try to reduce it to look like what we have in this place. So we'll have the first thing that we'll do is to multiply everything in the second row with minus 1, and then we'll have something like this. So multiplying this with minus 1, I'm just going to write out what we have in the second row. So multiply this minus 1 and have 0, and there we'll have 1, and here we'll have minus 1, and then in this place we will have minus 1 times y will give us minus y, and then trying to use what we have here to reduce this to be 0. That means we will be multiplying this by minus half and adding it to what we have in the first row. So we'll have row 2 comma 1 times minus 1 over 2. And so we'll have this times 0 will give us 0 plus 1, we have 1. Minus half times 1 will give us minus half plus half here will give us 0. And then minus half times minus 1 will give us half plus 0, and we'll have half here. And then minus half times this will give us half y plus this. And so we'll have 1 over 2x plus 1 over 2y. So we'll go to the third row. We try to use the second row to reduce the third row, and we'll have something like this. Right here we'll still have half, so we are going to multiply with the negative half. So we multiply this with 0, and we'll have 0 plus 0, we'll have 0 here. Multiply this with 1, we have minus half plus half, we have 0 here. Then we'll multiply this with minus half, we have half. Half plus 2, that will be 2 plus 1 over 2, and that will give us 5 over 2. And then we'll multiply this with minus half, and we'll have 1 over 2y, and we'll add it to what we have here. And right here we'll have minus 1 over 2x, then plus 1 over 2y, then plus z. So that's the new matrix, and then we try to reduce the third column to look like what we have here. So trying to reduce that, right here we'll have 5 over 2. So trying to reduce that to be 1, we'll be multiplying the third row with 2 over 5. And then we'll have multiplying the third row with 2 over 5, we have 0 here, and we'll have 0. And then multiplying this with 0 over 5, 2 over 5 will have 1. And then we multiply this with 2 over 5, and we'll have minus 1 over 5x. And here we'll have 1 plus 1 over 5x. No. Yes. And then multiply this, here we'll have z, I'll multiply with 2 over 5, so we'll have plus 2 over 5z. And then trying to use this to reduce what we have here. Right here we'll have minus 1, and we're going to use here to reduce it, so that will be row 3, or let's first reduce the first row, row 3 comma 1, and here we'll have 1 over 2, so we'll multiply with minus 1 over 2, and so multiplying that we'll have 1 here, and we'll have 0 here, and this times this will get 0 here also. And then multiplying this with minus half, we'll have 1 over 10, and then adding it to what we have here, I think we'll have multiplying this, we have 1 over 10, and then plus 2 plus 1 over 2, that means we'll have 10 here, and then we'll have 1 plus 5, and that should give us 6 over 10. And so there we'll have 3 over 5x. So right here we'll have 1 over 5y. Multiplying this with minus 1 over 2, we have minus 1 over 10. And then adding it to what we have here, 1 over 2y, that will give us minus 1 over 10. That will give us 4 over 10, which will give us 2 over 5y. And then multiplying this with 1 over 2, we'll have minus 1 over 5, and then uh, minus 1 over 5z. And that's it for the first row. And then we'll go to the second row. We use the third row to reduce the second row, and we'll have right here we'll have minus 1, so we'll be multiplying it by 1. And so we'll multiply this by 1, we add it to what we have here, we'll have 0, and here we'll have 1. Multiplying this by 1, we have 1 plus minus 1, we have 0 here. And then multiply this by 1 and add it to what we have here, we'll have minus 1 over 5x. And then here we'll have 1 over 5 minus 1y, and that should give us minus 4 over 5y. And then we have 2 over 5 here, so we have plus 2 over 5z. And once we are able to make what we have here to look exactly like this, then this becomes the inverse of our matrix. And so I'm just going to wipe up this place and then write out the coefficients. So I just wrote out the coefficients of the letters that we'll have here. First, in the first column we'll have x, and that's the coefficients, and then we have the coefficients of y and z, and that is the inverse of this matrix here. And so that's the fastest way that we can get the inverse of any matrix. And even though we are not able to solve this in 2 minutes, but I think this is a better way and a faster way to solve this. So thank you for watching.